Okay, now moving on to the next presentation, we have Victor M. Rada, a technical support manager at Runergy. He's going to talk on N-type technology, superior performance, and reliability. Victor?
See me? You can hear me well?
Yes.
Okay, I could share. I'm not allowed to share. Okay, I'm allowed to share now. Perfect.
Yeah.
Allow me to start the presentation. Okay. Okay, thank you for the introduction and special greetings to the audience, everyone watching right now or watching in the future. I understand this conference will be recorded, so hello to those. My name is Victor Rada. I am the technical support manager for the European region for the global PV business unit for Runergy. Runergy is a vertically integrated global PV cell and PV module manufacturing company. Now, thank you for the opportunity to present. My presentation today is going to be on N-type performance and reliability and also industry trends. The reason why we feel that we're in a special position to make a presentation on these topics is because we are a company that have two special types of customers. We have our final customers now because we sell modules, and this is exactly the market that we're trying to establish ourselves in. But we're actually already established as a PV cell manufacturing company, and our clients are PV module manufacturers. So at this point, we have a good set temperature on the industry trends, and we feel that this opinion is important to share. Our presentation today, we're going to take the opportunity to introduce Runergy to those that do not know us yet. So not our PV module manufacturers, that are our clients and their clients if they happen to read the BOM. So everyone else, we're going to take this opportunity. And then we're going to show you our roadmap with our outlook for the industry for the next year. And finally, we're going to share some data that we think is a validation and confirmation of what we were expecting to get from the N-type technology modules and cells that we're manufacturing and selling for the next year or two. And finally, some closing remarks with a special key takeaways that I want everyone to keep. So let's begin with the company profile. Runergy is a company that is relatively young. It was founded in 2013 by Dr. Tao. Dr. Tao, very well-respected founder, got his superior education in Fraunhofer ISA in Germany. And our company started as a PV cell manufacturing company with a strong R&D component. As an evidence of this, we have accumulated so far over 300 authorized patents, all focused and aimed at the actual industrialization and mass production of cells, which is remarkably different than the type of patents that you would expect to get strictly in a lab setting. And this is something that is remarkable about us. And well, the business has been going well along with the industry, to the tune that now by 2020, we were one of the top 3 PV cell manufacturers in China and thus the world. And by the end of last year, we had accumulated over 50 gigawatts of cells shipped. Now, our orientation in the business is that we expected to expand our capacity of cells. Now we have 25 gigawatts of PERC and over 38 gigawatts of N-type cell capacity. And this is the capacity we expect to have by the end of the year. And now we started the transition into also having activity in the module business. So we have expanded our capacity and we added over 20 gigawatts of module capacity. This is the value that we expect to have by the end of the year. We proudly, because of this, we proudly tout to be the first company to have a large N-type manufacturing facility of cells and modules outside of China. This is our manufacturing facility in Thailand, which is really important for certain geographies, particularly the United States. And before I move on to the other relevant factor of our company, I wanted to make sure that I mentioned that recently we got the Tier 1 rank by Bloomberg, which is very important for the bankability of our products and the company. And that we expect soon to also be listed in the Shenzhen Stock Exchange. We're going to be a public traded company, also important for the bankability of our future projects. And just in case you have related to our company before. Hyperion is a brand that was launched recently, and this is how we're better known in the States. So this is one of the two names that are associated with our company. And this is particularly in the United States. And talking about the United States, it's where the next point is really interesting. We are a global company because we manufacture outside of China and in China and everywhere in the world. And we sell everywhere in the world. But most importantly, we're vertically integrated. And we would like to say we're truly vertically integrated because we're one of the few companies that outside of China happen to that manufacture cells and modules, but we also have the entire supply chain. And by the entire supply chain, we mean, of course, not only the modules, the cells, but also the wafers, but also we have polysilicon capacity and everything that goes behind. So we have a metallurgical grade silicon factory and a quartz mine. So Runergy Group owns and operates the entire supply chain that is necessary for the manufacturing of cells and modules. And the original reason why we made this decision to do a full vertical integration was to ensure the reliability of our supply for our clients. So when we manufactured the cells, we wanted to make sure that we were impervious to market volatility or supply chain limitations or fluctuations. So we integrated vertically. And now at this point is also very interesting because it allowed us to develop quality assurance and quality control protocols over the critical steps and processes associated with the raw materials and the precursory materials to the manufacturing of cells and now modules. So we have been able to develop good quality control protocols and control over the wafer and ingot manufacturing, and of course the cell, which is where we excelled at until recently. We have gained the trust of the most well-renowned PV module manufacturers in the planet, and what we expect to make is a transfer of this trust from the quality control and the quality of the process and manufacturing of the cells now into the modules as well. So this is something that is remarkable of our company because we're one of the few that have this full vertical integration. Another thing that is remarkable of our company, if you think about it in the supply chain sense, is that the fact that we have control over the entire supply chain means that regarding the supply chain traceability requirements that are coming up recently in the markets that many clients are starting to look into, both of our clients or both of our types of clients benefit significantly from having a supplier, particularly of cells or modules, that has full control under the same documental system of all these materials, so the raw materials and the precursory materials that lead to the cell and the module. Because then when the audit comes, it's that much easier and that much more expedited to get a positive result in a perfectly functioning, perfectly well report. So this is beneficial for the inspectors, beneficial for our clients. When we sell them ourselves, they can get that traceability report done quickly, and then they can give them to their final customers. And now when we get our customers for the modules, we can also provide this easy of access to the information and the complete traceability. Now, this is important because these traceability audits are very thorough and they're very complex. And just to give everyone a bit of perspective, and this is a piece of value that I wanted to share with you, I extracted a very cursory bird's view eye of all the different invoices and documentation that has to be checked from the module or from the cell back to the full traceability of the supply chain of the material. And of course, you can imagine that it's very complex, but just look at all the tiny documentation that has to be traced all the way up. You can of course think that you need the module serial number or the batch number, and similar to the solar cell. But if you start to think that, you also have to start looking into the warehouse inventory control, the material requisition numbers of the cells, and also do something similar for the wafer. And so far so good, but then you also have to do that same type of control for the ingot from which that wafer comes from. And it starts to get more complicated once you go into the polysilicon, because now you have a multiplicity of sources and suppliers from which all of them could bring you potentially trouble if you're trying to do your supply chain traceability. And the industry has been having some trouble in ensuring this as of late. But then imagine if you have everything under control, then you can actually go and still go back directly into the warehouses of the metallurgical grade silicon or the silica powder, and also do a similar invoice tracking, warehouse control, and that will bring you all the way to the quartz mine, which is something that is remarkable. We know that our clients appreciate this, and we make sure to make it known that this is a particular service, a distinguished service that we can offer with our products. Now, let's look at the product catalog that we can offer. We know that the standard in the industry is the PERC. This is non-controversial, and that the following in the technology that will be established in the market is going to be the N-type cells. This is already happening. It's well known and accepted. These N-type technologies are better known in the market as the TOPCon and the heterojunctions, but we particularly refer to them as N-type specifically and heterojunction for reasons that are obvious. We see from our perspective, from the demand that we see from our products, from both types of clients, is that these two technologies have sufficient demand, and we expect them to be the mainstream technology for at least for the next year and probably for the next two. And we also expect them to be the base of the technology of cell technology for whatever the next step is going to be. So it was mentioned before that maybe tandem cells. And it stands to reason that one of these two cells, this new upcoming technology, so the N-type or the heterojunction, is going to be the base for that next step coming up in the future. On this, ourselves, looking at the demand that we get from our cells and modules, we see that these are going to be probably the most demanded and most popular product. So this is what we offer for the residential market. We see that the most popular product is going to be an all-black module, slightly smaller to accommodate for the regulations of the rooftops, with, of course, all the standard performance and guarantees that everyone offers, because, you know, the critical component of the module is the cell. So if we make cells for other manufacturers, of course, they have to provide the same performances and guarantees that we offer. So this is exactly what we offer. And for the industrial scale products, we offer also the standard N-type 142 half cell module. We see that there's significantly more demand for the smaller 72 cell module than for the 78, but they're both offered and they both get good demand. And of course, we offer them at the standard performance and guarantee that is standard now in the industry for N-type modules and N-type cells. Now, for the future, and by the future we mean the real close future, we see that the industry is going through some changes, or it's been discussed, at least in the media and amongst the PV module manufacturers. And this is related, as you heard before, on the change of the wafer size and, of course, the cell size, which would have an effect on the module size. And not only that, but there's also a difference in, even though the standard size of the module is being established, there might be a difference on the actual size of the cell, which may have a difference in the electrical parameters of the module. And what we see is that there's no clear trend right now as to which design, internal or external of the module, is going to be dominant. So we are ready, and we actually do offer both size and both dimensions of modules. So the standard that we have right now and what's upcoming in the new standard. And this is what we see as manufacturers and suppliers to our clients, that there's no clear trend. We are reactive in this sense. We believe that the customer is always right. So we expect to see a response in the demand that will allow us to make a unification in the products that we offer. But so far, we have to be ready to offer all these options because none is actually the clear winner so far. And one thing that we see in the near future is that definitely heterojunction in some markets makes perfect sense. It's actually more economical and more profitable for everyone. So from our R&D department, we foresee that we should be able to manufacture cells at a mass scale, so an industrial scale, heterojunction cells by the latter half of next year. So by Q3, Q4, we expect to be able to supply heterojunction modules and, of course, heterojunction cells. So this is what we're looking into. Of course, this module is going to be much larger for reasons, again, that are obvious for the industrial scale mostly. And this is what we foresee for the next future, for the near future. Now, I also wanted to show you the technology roadmap for our cells. Here in this graph that I got straight from our R&D department not too long ago, it shows the transition that we're seeing from P-type to N-type. This transition is obvious because of It's adaptable, one type of process to the other. So you go from PERC to N-type, and it makes perfect economical and technological sense. And this is the efficiency trend that we expect to see. And the efficiency trend has a corresponding power roadmap on the module. Now, of course, if the size of the cell and the size of the module varies, then you're going to see a corresponding variance in the power bin distribution and the maximum power that may be labeled on the modules. And this is what we're expecting. Again, like we said, since we don't know precisely what is going to be the dominant cell size and module size, but we're ready to provide everything. We have to be ready to make a roadmap based on all these possible dimensions. And this is the roadmap that we've been coming up with. You can also see that even though we're not ready for mass production, we have enough data to provide a good outlook on what we expect the power to be on the future heterojunction modules, and as well as the N-type modules that we expect to sell in the next year or two. Now, let's go over some data that we've been able to gather from our N-type cells and modules, which is relevant. We of course, we're not expecting any surprises, and that's exactly what we got. Before we go there, I just wanted to show here, I know, again, non-controversial for this audience, but the typical cross-section of a p-type and an n-type cell, just so that we know that what we're talking about. N-type means, of course, passivated with the tunneling oxide. That's the critical step in the SET technology of the n-type cell. And we know that this has consequences, of course, this is expected to have consequences in the efficiency and performance and reliability, durability of these cells and modules. And this is what's accepted already in the industry, that N-type cells should have higher efficiency, higher performance at low irradiance. They should have better temperature coefficients, and they also should be more resistant to specific types of degradation or of child mortality incidences like LID or PID. And this is, of course, related to both higher quality in the manufacturing of the wafers and the ingot. This is mostly related to the LVTID and LID, and the fact that it's an N-type wafer. And of course, the technology itself of the cell allows it to have this better performance and this better performance in the field as compared to PERC. Okay? We bear this to be true because we've been seeing in the media, we see it everywhere, and we have some validation of our data ourselves from pilot plants. This is a pilot plant that we have in China, where we have compared the performance, the energy output of N-type modules and exactly corresponding P-type PERC modules. And what we have seen is that we get an energy gain that corresponds to the reported efficiency increase in these types of modules, which is not surprising. Again, this is validation and confirmation of what we were expecting. And we see this happening every month. So in every condition, we see reliably and consistently this improvement in the power output. And this is exactly what we were expecting to get. And the other aspect that is important of this type of technology, both for us, ourselves, and our clients, is not only to know that the energy output is going to be as reported, or better than PERC, but also that they're going to have superior reliability and durability. Now, it's accepted in the industry that there's no real substitution. So the only reason to measure reliability and durability is to actually do a field test for the duration of the lifetime of the product, but this is not viable. So we have good proxies for this measure. And what we have accepted for ourselves as our own quality control, and that the market is accepting, are the reliability testing protocols. So of course, there has to be really good quality control, looking closely at all the components, because anything that could go wrong in the manufacturing of a module or of a cell will have an effect on the output and the durability of the module. But granted that you have good quality control of all these components, then this extended reliability testing protocols and the reliability testing sequences are a good proxy for what the module should expect to bear in the field. And what we have seen is that at least the results that we get from our labs and that we have been getting from our modules and many other manufacturers of these N-type modules is that the performance is at least as good as the P-type, in many cases even better. And this, we think, again, this is confirmation and validation of something that we were expecting and we're glad to see. That means that this technology should be at least as highly regarded as the standard established per technology is already, and even better. If this is anything to go by, the RATC, for example, gave us to our product, so our cell and our module, a highest achiever overall result with really good degradation values, very low degradation values in any of the sequences that are tested in the extended reliability testing protocols. So this is remarkable for the technology and for our clients as well. Now, I wanted to give you the closing remarks because time is running out. The intention of this presentation was first to get you to know Runergy as a company. We are very well established as an R&D and PV cell manufacturer, but I also wanted as a key takeaway that we're also selling modules now, and we are remarkable because we have this type of sense of the market, because we have two types of clients, and we also are truly vertically integrated, which is remarkable. Not everyone actually can say that in their group they control everything from the quartz mines to the polysilicon and of course wafers, cells and modules. What we see from our grasp in the industry, the tendency is that of course N-type cell production and modules are going to be mainstream and dominating the market for the next year or two. However, there's no clear tendency on what size of cell and what type of module. We're at the expectation of seeing where the demand will lead us. And what we see is that this new technology that we're offering is giving superior performance than the standard, and with good enough reliability. So this is good news for us and for the industry, knowing that this technology has superior output and superior reliability as well. Well, thank you so much for your attention. This was our presentation. I hope I counted on time. I didn't have a watch in front of me. Sorry.
Yeah, you covered it on time. Victor, so very brief question, because you really consumed the total 20 minutes. So you showed that you were offering a 1.6 millimeter based glass, double glassed module for the residential applications. So is it also recommended for harsh environments, even for the rooftops like US, where you could have hails and, in some areas, there are some concerns about the hail. So is it any selective places where you are marketing this product, or is it global?
Our main market for the residential, so the all black module, is actually in Europe. But in those areas that actually would make sense to have superior durability because of hail, like you said, that is the reason exactly why we are also looking into providing a backsheet option. I think we can actually provide it already. And this backsheet option actually has a thicker front glass, not so that the compromise in the weight is not too great. And this is actually our recommendation. If in the case, as it happens in most of Europe, that there are no truly severe meteorological conditions or no truly great hailstorms, then this type of module will make sense because it increases the reliability without increasing the weight so much. But we also have this other option, and this is a principle that should be applied in most cases. If you're going to apply or install modules in an environment that's particularly harsh, then it would make sense to either modify the BOM to accommodate for this, or to actually make sure that you run a battery of tests that ensure you that you have built the module to withstand these conditions. So yes, good question, and that is the reason why we have this product in our catalog as well.
Okay, I think there are a few questions in the chat window. Please stay back and enjoy our conference while answering to these questions.
Of course, thank you so much.
Thank you.